Welcome to E-Shiksha by Brajesh. Today we will learn to 3D shapes. Sphere. The term sphere can have various meanings depending on the context in which it is used. Here are a few possible interpretations. Geometry. In geometry, a sphere is a three-dimensional geometric shape that is perfectly round in all dimensions, much like a ball or a globe. It is defined as the set of all points that are equidistant from a central point. Astronomy. In astronomy, a celestial sphere is an imaginary sphere with the Earth at its center. It's used as a tool for locating objects in the night sky, and stars are often described in terms of their positions on the celestial sphere. Physics. In physics, a sphere can refer to a volume of space or an object that is approximately spherical in shape. Medicine. In medicine, sphere is an acronym for systolic pressure estimation from histogram of event-related responses, a method used for blood pressure measurement. Technology. In the context of technology, sphere can also be an acronym for various software, organizations, or projects. Without specific context, it's challenging to determine which one you might be referring to. If you have a specific context or meaning in mind, please provide more details, and I will be happy to provide a more specific explanation. Cube. A cube is a three-dimensional geometric shape that has 6 square faces, all of which are congruent, meaning they are the same size and shape. Each face of a cube is perpendicular to the adjacent faces, and all the edges are of equal length. In a cube, faces. A cube has 6 faces, and each face is a square. Edges. There are 12 edges in a cube, with 3 edges meeting at each vertex. Vertices. A cube has 8 vertices, corners, where 3 edges intersect. The formula for calculating the volume, V, of a cube is V(S)(3), where S represents the length of one side of the cube. The formula for calculating the surface area, A, of a cube is H(S)(2), where S represents the length of one side of the cube. Cubes are a fundamental geometric shape used in mathematics and have applications in various fields, including geometry, engineering, and computer graphics. They are also commonly used in games and puzzles, such as the Rubik's Cube. Cylinder. A cylinder is a three-dimensional geometric shape characterized by 2 parallel circular bases connected by a curved surface. The bases are congruent, meaning they have the same size and shape, and the line connecting the centers of the 2 bases is called the axis of the cylinder. Here are some key properties and formulas associated with cylinders. Volume of a cylinder. The volume of a cylinder can be calculated using the following formula. VRH, where V is the volume of the cylinder. Pi is approximately equal to 3.14159, R is the radius of the base of the cylinder. H is the height of the cylinder, the distance between the 2 bases. Lateral surface area. The lateral surface area of a cylinder refers to the surface area of the curved side, excluding the 2 circular bases. It can be calculated using the formula lateral surface area dou RH, where pi is approximately equal to 3.14159, R is the radius of the base of the cylinder. H is the height of the cylinder. Cylinders are common in everyday life and can take various forms, such as soda cans, pipes, and even the shape of some buildings. They are widely used in engineering, architecture, and mathematics due to their simple and versatile geometric properties. Cone. A cone is a three-dimensional geometric shape that resembles a solid figure with a flat, circular base and a curved surface that tapers to a point called the apex or vertex. Cones are classified as a type of pyramid since they share some similarities with pyramids, but cones specifically have a circular base. Key characteristics of a cone include: base. The bottom face of a cone is a flat, circular shape. The size of the base determines the size of the cone. Apex, the top point of the cone, where all the sides converge. It is also called the vertex. Height. The height of a cone is the perpendicular distance from the apex to the center of the base. Slant height. The slant height is the distance from the apex to a point on the edge of the base along the curved surface. Lateral surface. The lateral surface of a cone is the curved part that connects the base to the apex. The formula for the volume, V, of a cone is given by V 1/3 R2H, where pi is approximately 3.1415. R is the radius of the base of the cone. H is the height of the cone. The formula for the lateral surface area, A, of a cone is given by AR, where pi is approximately 3.1415. R is the radius of the base of the cone. Pronounced as L, is the slant height of the cone. Cones are commonly encountered in various real-world objects and scenarios, such as ice cream cones, traffic cones, and the geometric shape of certain volcanoes. They are also important in mathematics and geometry for their properties and applications in solving problems related to volume and surface area. Pyramid. A pyramid is a three-dimensional geometric shape that typically has a polygonal base and triangular faces that converge at a single point called the apex or vertex. Pyramids come in various forms and are commonly classified based on the shape of their base. The most common type of pyramid is a square pyramid, which has a square base. Here are some key features of a pyramid. Base. The base is a flat, two-dimensional polygon that forms the bottom of the pyramid. The shape of the base can vary. It can be a square, rectangle, triangle, pentagon, hexagon, or any other polygon. Apex. The apex is the point at the top of the pyramid where all the triangular faces meet. Faces. A pyramid typically has triangular faces that connect the edges of the base to the apex. The number of faces depends on the shape of the base. A square pyramid, for example, has 4 triangular faces. Edges. Edges are the line segments where two faces of the pyramid meet. The number of edges also depends on the shape of the base. Vertices. Vertices are the points where the edges of the pyramid meet. The number of vertices varies depending on the base shape. The volume of a pyramid can be calculated using the formula V13 base area height 31 base area height, where V is the volume of the pyramid. Base area is the area of the base polygon. Height is the perpendicular distance from the base to the apex. Pyramids are common in geometry and can be found in various architectural and engineering structures, including ancient pyramids like the Egyptian pyramids, as well as in everyday objects and designs. They have been used for their stability and aesthetic appeal throughout history. Triangular prism. A triangular prism is a three-dimensional geometric shape that has two triangular bases and 3 rectangular or parallelogram faces connecting the corresponding sides of the two bases. It is a type of polyhedron, which is a solid figure with flat faces, straight edges, and sharp corners, vertices. Key characteristics of a triangular prism include: bases. Triangular prisms have two identical triangular bases. These bases can be equilateral, isosceles, or scalene triangles, depending on the specific prism. Lateral faces. Triangular prisms have 3 rectangular, or parallelogram, lateral faces that connect the corresponding sides of the two triangular bases. Edges. Triangular prisms have 6 edges. 3 of these edges are the edges of the triangular bases, and the other 3 are the edges of the rectangular, or parallelogram, lateral faces. Vertices. Triangular prisms have 6 vertices, where the edges meet. 2 vertices are at each of the triangular bases, and the other 4 are located where the lateral faces meet the bases. The volume of a triangular prism can be calculated using the formula volume, Adha, base area height, where base area refers to the area of one of the triangular bases. Height is the perpendicular distance between the two bases. The total surface area of a triangular prism can be found by summing the areas of its 2 triangular bases and 3 lateral faces. Triangular prisms are commonly encountered in various everyday objects and structures, such as certain types of buildings, packaging materials, and geometric shapes used in mathematics and engineering. They are also a fundamental concept in geometry and mathematics education. Hexagonal prism. A hexagonal prism is a 3-dimensional geometric shape that consists of 2 parallel hexagonal bases connected by 6 rectangular faces. It is classified as a type of prism because it has constant cross-sectional shapes, hexagons, along its length, and the bases are parallel and congruent. Here are some key characteristics and properties of a hexagonal prism. Bases. A hexagonal prism has 2 hexagonal bases that are identical in size and shape. These bases are parallel to each other and aligned in the same direction. Faces. A hexagonal prism has 6 rectangular faces that connect the corresponding sides of the 2 hexagonal bases. These faces are also called the lateral faces. Edges. A hexagonal prism has 12 edges in total. Each edge is formed by the intersection of 2 adjacent faces. Vertices. There are 8 vertices, corner points, in a hexagonal prism. Each vertex is where 3 edges meet. Cross-section. If you were to cut a hexagonal prism perpendicular to its length, the cross-section would be a regular hexagon, which means all its sides and angles are equal. Surface area. The total surface area of a hexagonal prism can be calculated by adding the areas of the 2 hexagonal bases and the areas of the 6 rectangular lateral faces. Volume. The volume of a hexagonal prism can be calculated by multiplying the area of one of the hexagonal bases by the height, the distance between the 2 bases. The formulae for calculating the surface area, Sa, and volume, V, of a hexagonal prism are as follows. Surface area, Sa, Do, area of a hexagonal base, plus Che, area of a lateral face. Volume, V, area of a hexagonal base, height. To calculate these values, you'll need to know the dimensions of the hexagonal base, such as the length of one side, and the height of the prism. Hexagonal prisms are commonly encountered in various real-world applications, such as packaging, architecture, and engineering, due to their unique shape and stability. Taurus. A torus is a geometric shape that resembles a donut or a ring. It is a 3-dimensional object characterized by its circular cross-section and a hole in the center. The term torus is derived from the Latin word for cushion or bulge. Key features of a torus include circular cross-section. If you were to slice a torus perpendicular to its axis, the resulting cross-section would be a circle. This circular shape remains consistent throughout the torus. Hole in the center. A torus has a hole in its center, often referred to as the central hole or the inner circle. The distance from the center of the hole to the outer edge of the torus is called the major radius, while the radius of the circular cross-section is the minor radius. Symmetry. A torus has rotational symmetry around its axis. You can rotate it around this axis, and it will look the same from various angles. Tauri, plural of Taurus, are commonly encountered in mathematics, physics, and engineering. They have various applications in fields such as geometry, topology, and even in designing objects and structures in engineering and architecture. In mathematics, the study of Tauri is part of the broader field of topology, which deals with the properties of shapes and spaces that are preserved under continuous deformations. In everyday terms, you can think of a torus as a shape that resembles a donut, a life buoy, or a bagel, with a hole in the middle. It's a simple yet interesting geometric object that has applications in various areas of science and engineering.